कौशल राजन संदीप अरे चेन्नई को
Hi, good evening, everyone. Am I audible?
Yes, ma'am.
Okay. So this is week 5, second session. So today we are going to discuss the practice assignment. Uh, One sec. Let me share my screen. Is it visible to you?
Yes, ma'am.
Okay. So before we start, can anyone tell me what is the list?
It's the collection of items.
Collection of all
So are
items.
okay. So are there any constraints on what type of items we can store inside a list?
No, there is no constraint.
So can I inside a list can I have both integer and string type items if I want?
Yes.
Yes,
Okay. Now see this list. This is list L. What will this give?
Element 10.
10.
Okay. This
50.
this
20.
20, 30, 40, 50.
List of
20 up to 50. Okay. And this init of L
10, 20, 30, 40.
10 up to 40. Okay. So the basic functions and all you know about list. So list is a type of a collection, right? Okay. So let's start with the contents of practice assignment. Okay. This is the first one. So the following pseudocode is executed using scores dataset. Let S be the list of sequence numbers of students having marks greater than 75. So marks has to be greater than 75 in at least one subject. At least means what? Less than equal to or greater than equal to?
Greater than.
Greater than equal to, right? This is at least. Less than is at most. So S is the list of sequence numbers of students having marks greater than 75 in at least one subject. That means in one or more subjects. So what does S list represent at the end of execution of the pseudocode? Okay. So S list is initially empty. So while table 1 has more rows, we are going to iterate through the scores data set. So every time you read a card, now you will enter a for each block. So for each C in S. Again, what is S? S is a list containing what? Sequence numbers or let's say IDs of students. What is the criteria that they have scored greater than 75 in at least one subject? It is a list of those students. So for each C in H, that means we will pick each of the IDs from this list. If the current card that you have picked, if the sequence number matches, that is, if the ID matches, okay, then you will enter the nested if. So nested if condition is what? The current card that you have picked, the mathematics marks, is it less than 75? And physics marks, is it less than 75? That is, if both these conditions are true together, that the student currently that you have picked has scored less than 75 in both maths and physics, but they are present in the S list, this S list. Then in the new empty S list, we are adding their sequence number. So tell me one thing. In list S, this one, we are storing IDs of students who have scored greater than 75 in at least one subject. That means one or more subject. So now let's say I have picked a card whose sequence number matches with a sequence number in this S list. That means this person has scored greater than 75 in at least one subject. But again, this condition is also true that they have scored less than 75 in maths and physics. That means what can we infer from that?
He has got more than 75 in chemistry.
Right. That means X dot chemistry score has to be greater than 75 in order to fulfill this criteria. Right. Okay. So S list in that case will be appended with the current that student's student ID or sequence number. That means this S list is a list of which students?
All the students who got more than 75
Greater
in
than
chemistry.
75 in
Yes.
chemistry and only chemistry, right? Okay. Now check the options. Which one?
Ma'am, is this doubt session?
No, this is practice assignment for week 5. We're solving the
B.
practice questions. Yeah, which one are you saying?
Option B.
Option B. Okay. Anyone else saying any other option?
Option C.
Option C. Any other options? So if I come to option B, list of sequence number of students who have scored more than 75 in chemistry. That means chemistry greater than 75 is fulfilled. But it is nowhere mentioned that that student has also scored less than 75 in maths and physics, which is a valid condition because that is the nested if condition. This has to be true. So this option will also take into account those students who have scored greater than 75 in maths also, in physics also, right? But in option C, it is list of sequence number of students who have scored less than 75 in both maths and physics. This is the first criteria, but more than 75 in chemistry. So people who have scored greater than 75 in only chemistry. So this is the correct one. Is it clear why B is wrong?
Yes, ma'am.
Okay. So option C is correct. This is easy question. Now question 2. This one is on your words data set. Okay. So again, what does each card in words data set contain? It contains a word, its part of speech, letter count, and ID or sequence number. So assume that the rows in table 1, that is words data set, are sorted in increasing order of sequence number. Right. So starting from sequence number 0, 1, 2, 3 like this. What will word list represent at the end of execution? So we can say initially L is an empty list, flag is a boolean variable set to true, and word list is an empty list. We have to find out what this word list represents at the end of execution. So now we come into the while loop. Now this is where we iterate through all the cards in words data set, which are sorted in ascending order of sequence number. So you read the first card, you check if flag. This will be true when flag is true. So initially flag is set to true. So if flag will be true, so we will enter the if block. Then in L, the empty list, we will append what? The current word of the card that I have picked and set flag to false. Okay, now come to the next step. If X word ends with a full stop. So if I'm working with a sentence, let's say I am a student. This is my sentence. So this is the first word. So currently I'm working with this word I. Right, now flag is set to false. In L list, what do I have? This word I. Right, I have appended it. Flag is set to false. Does this word end with a full stop? No.
No.
So none of this will happen. I won't be able to enter this if block. So I will go for the next iteration. Pick the second word am. Now what is flag? False. So I won't be able to enter this if block. Again come to the second if. This also doesn't end with a full stop. So I will skip this if also. Go for the next word this. Again same thing, flag is false. Word doesn't end with full stop. So go for the next word student. This ends with a full stop. So even though the first if is false, because flag is still false, we will come to the second if and X word ends with a full stop. So now my condition is fulfilled. So I will enter the if block and append this last word into L list. So now L list contains what? I comma student. Right? Now L list is again reinitialized to an empty list. Before that, what is done? The current L list is appended to word list. That means word list is a list of lists. Right? It is a list inside which there is another list which contains I comma student. Okay. First you appended the last word of the sentence to L list, then you append L list itself to word list. So word list is a list of lists. Then you reinitialize L list to an empty list and flag is again set to true. So what is this basically doing? In every iteration of the while loop, so we are basically going through every sentence, right? We are taking the first word and the last word of each sentence and we're taking that in L list, right? Once you are at the end of a sentence, you will append your L list to your word list as an element, right? Then L list is again reinitialized to empty list before you start the next sentence and flag is set to true. Similarly, flag will again be set to false once you are done with the first word of the next sentence, right here in line 7. So the same process will continue. That means word list will contain what? It will contain number of lists, right? And each list contains first and last word of every sentence. Is this correct?
Yes, ma'am.
Yes, ma'am.
So which option is correct? What is word list? Ordered pair means first word comes first, then last word, not last word comma first word. Right? The ordering has to be maintained. So list of ordered pairs of first and last words of each sentence of words data set. Everyone is agreeing with this?
Yes, ma'am. A option.
Okay, let's see. Correct option is A. Why the other options aren't correct? So list of first and last words of each sentence of words data set. That is not correct because it is a list of ordered pairs, right? Again, option C, list of ordered pairs of last and first words. So here ordering is not correct. First the first word, then the last word. And option D is list of words of first and last sentences is obviously wrong. So option A is correct. Now this is a comprehension
Excuse me,
question.
ma'am.
Yeah.
So, ma'am, when will option C be correct? Like, what will change? Where will change so that option instead of A, it will be C?
See, here, since I'm appending here, right? First, the first word is appended. Now, if you want C to be correct, then you will append in the beginning. The last word you can append in the beginning. So it can be like this, X dot word plus plus L. So now the last word will come in the first half of the ordered pair. So it will be last word, then first word.
Okay. So, if it is written afterwards, then it goes to the back.
Yeah. You're
And
appending from the end, right? That means it will come to the back.
okay. Thank you, ma'am.
Okay. So comprehension type question. So L is 0. L is a single list containing one item, 0. LA is a list of lists. Here each element is also a list, right? LB is an empty list, LC is an empty list. This question it has come multiple times in quiz 2. Okay, very common question. I can say this is important. Look, for each A in LA and for each B in A, so there is a nested iteration we can see. You have to do these two lines, then come out, perform these two lines, then again go for the outer iteration. So we will do this with the help of the example, right? So the first question is asking what will be the value of L at the end of execution. So let's see. Okay, so L is initially this, LA, LB, LC, everything is given to us. Let's start with the iteration. So first iteration of outer for each. That means this, line 4, this for each block. So for each A in L of A, what is the first A in L of A? LA,
List of.
this one, right?
Yes.
This.
Yes.
Now for each B in this A, how many elements are present in this? 1. So how many inner iterations will be there? 1. Right? Now first and only inner iteration in this case. What is this B? 1. Right? So currently my A is this, my B is this, the element. So in LB, you are appending from the beginning. So what will LB look like? Currently LB is empty. So just append the element like this. And in L, what am I storing? First of L. Currently L is what? This, 0. What is first of L here?
0.
L is this. First of L is 0. Plus B. What is B? 1.
1.
0 plus 1, 1. Okay, inner iteration. Will there be any more inner iterations? Are there any more elements in A?
No.
No. So come out of the inner for each block. Come to line 9. We have to update LC. So in LC, what am I appending? LB, this entire list. But from the beginning, we are not appending from the end. So LC will contain what? Initially LC is empty. LB contains what? This. So right now LC looks like this. Is this correct?
Yes, ma'am.
Now LB is again reinitialized to an empty list. Okay. This is the first outer for iteration is completing here. Now we are going to go for next second outer iteration. That is second iteration of this line 4 for each block. So in this iteration now what is A?
List of 1 and 2.
This one, correct. So A is 1, 2. For this, how many inner iterations will be there?
2.
2. Let's do the first one. First inner iteration. What is B?
1.
1. LB. Remember LB was
Empty.
reinitialized empty. So LB, we are again storing this 1. Okay. What is L? In L, we had stored this 1. So this is
1
L
plus 1.
currently. Okay. So first of L is 1 plus B is also 1. So L is now 1 plus 1, that is 2. Okay. Now second inner iteration. What is B?
2.
2. What is LB?
2.
1,
List with 1.
What will come first, 2 or 1?
1.
2.
1. 1.
Where are you appending from? Beginning
2,
or end?
1.
Beginning.
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 So
2,
2 comes first, then 1. Yes, 2, 1. Now L. What is first of L now? 2. What is B? 2. So L is now 2 plus 2. That is 4.
4.
Any more inner iterations?
No.
No. A is exhausted. So come out of the inner for each. Come to line 9. LC. So LC last contained this. Now you add your current LB, but from the beginning. So now LC looks like this. 2, 1 and 1. This is your current LB. Up to this, is it fine?
Yes,
Everyone?
ma'am. Yes, ma'am.
Okay. Now again reinitialize LB to empty list. Now we'll do the final outer for each iteration. So third outer iteration. What is your A? See,
List of 1, 2, 3.
1, 2, 3. How many inner iterations?
3.
Okay, let's do the first one. So again LB is reinitialized to empty list. Okay. What is the B? First B,
1.
1. LB, 1.
1.
Okay, LB was reinitialized to empty list. L,
Yes.
what was L? 4. In the last iteration, L was 4. So what
Yes.
is first of L? First of L is 4 only.
4.
plus the current B, that is 1. So now
5.
this is 5.
Hmm.
Okay. Go for the second iteration, second inner iteration. Okay. B is 2. LB now becomes, what is
2,
LB?
2,1.
2, 1. L now becomes, what is first of L? 5 plus
5
current B,
plus 2.
2.
means L is 7. Right? 5 plus 2. Third inner iteration. LB is what? B is what? 3.
3.
LB is 3, 2, 1. What is L?
10.
7 plus 3, 10. No more inner iterations, right? All 3 elements are exhausted. So now come out. LC. Now we have to update. I'm writing here. LC was previously this. Now you have to add your current LB, which is this one. So LC now looks like 3, 2, 1, then 2, 1, then 1. This list of lists. And LB is again reinitialized to empty list. But will there be any more iterations of the outer for each?
No.
This, we have gone through all elements in LA. So at this point, the question is asking what will be the value of L? What is L finally storing? It's. So which option?
B.
D. Is this clear? The iterations are clear for everyone?
Yes, ma'am.
Can you
Yes.
differentiate between list of lists and how to append from beginning, how to append from end, right? You know the difference now. The ordering is very important in lists, right?
Yes.
So now the second question is what will be the value of LC at the end of execution? So we already have LC, it is this list of lists. Let's check the option. Which one?
Third.
C.
C. C.
Okay. So this is a pretty straightforward question. You just have to do the correct way in the iterations. So you always write these type of questions. Don't do it in your head. Okay. Anyone has any doubt in these last 2 questions?
No, ma'am.
Question 5. Okay, this is a 5-mark question. So let a sentence is said. This is a bit of a long English. Basically, a sentence is said to be ideal. That is, what is an ideal sentence? If it has at least one verb and exactly one noun, or exactly one pronoun, but not both. That means it has to have one verb. Either it has one verb and one noun, or it has one verb and one pronoun. But it cannot have one verb, one noun, and one pronoun. This is wrong. Right? Either this or this. The following pseudocode is executed using again your words data set. At the end of execution of the pseudocode, count stores the number of ideal sentences. So how many such ideal sentences are there? And S list stores the list of the words in the ideal sentences. Okay. So count is a variable that stores the count of ideal sentences. S list is a list of the words in ideal sentences. That means for each sentence, there is going to be a list inside which there are the words of that sentence, right? So it is a list of lists. But the pseudocode may have mistakes in one or more lines. We have to identify the mistakes. Okay, it is an MSQ. So first, tell me if count is 3, that means there are 3 ideal sentences in my words data set. How many elements will be there in S list? Elements. If I have 3 ideal sentences.
I have 3 lists.
3.
3
Number of
elements, 3
sentences.
lists. Right. Because in S list, each element is a list which corresponds to what? Each ideal sentence. So each list contains the words from that ideal sentence. So if there are 3 ideal sentences, then S list will have 3 elements. Each of them is corresponding to one ideal sentence. Each list contains words from that ideal sentence. So S is a list of lists, S list. Okay, now let's go through the pseudocode. So initially A0, B0, C0, count 0. S list empty, W list also empty. So let me just mark the braces one. This is brace 1, brace 2 closes here, brace 3 closes here, brace 4 closes here, brace 5, brace 6, brace 5 closes here, 6 closes here, 1 closes here. That means the whole thing is inside the while loop, this outer while. Okay. Now inside we read each of the cards from words dataset. Now every time you read a card from word dataset, you are going to append that to the W list. Okay. So W list is basically a list of words, every word that you read. Okay. So let's take a sentence. So for it to be an ideal sentence, it should contain one verb and one noun, or one verb and one pronoun. So I can say that he what should I have? Tell me a sentence.
He likes apples.
Like Ram is
He
eating.
likes apples. This is a good sentence. Okay. Pronoun I have, verb I have. This is a ideal sentence. So it should be counted. Okay. So first word I read is he.
Ma'am, here apple is a noun.
Oh, apple is also a noun. No, we can't have this. So what should we do?
He likes eating. He likes running.
Eating is also a verb.
At
We
least
should
one.
have at least one. Okay, no problem. So he likes running, let's say. Who likes running? So this one should have greater than equal to one verb and one noun, and greater than equal to one verb and one pronoun. Either one of these. At least one verb. So first word is he. Okay. He is appended to W list. Now W list contains he. If part of speech is noun, this is not noun, so A will not be incremented. Part of speech is pronoun, yes. So B becomes 1. Part of speech is verb, no. So A and C are still 0. Next, if word ends with a full stop, no. So I will skip this whole part. I cannot enter the nested if also. Move it to table 2. Okay, go for the next word, like. Again, append it to W list. So now W list contains he, comma, like. Okay. Again, likes is not a noun, so A is not incremented, not a pronoun, B is not incremented, but it is a verb. So C is now 1. Again, doesn't end with full stop, so you can skip this whole thing, go for the next word, running. Quickly add it to W list. So he likes running. All of them are now in W list. Which one will be incremented, A, B, or C? Running is a verb.
C.
C is incremented. So C now becomes 2. Does it end with a full stop? Yes. So now come into the inner if. If A plus B is equal to 1, do A plus B. Here it is 1, right? A is 0 because there are no nouns here, and B was 1 because of the one pronoun. So A plus B is 1, and C is less than equal to 1. So
It should be greater than equal to 1.
correct. Why? Because C is the count of verbs, right? And we want at least one verb. So at least symbol I've told you is greater than equal to. So this is one mistake. So line 17 is definitely wrong. Now if I fix the mistake, let's say if I change it to greater than equal to 1. Then for this sentence, all the criteria are satisfying? Yes, no.
Yes.
Yes.
There is either one pronoun or one noun. That's why A plus B is 1. If it was 2, then it would have been non-ideal sentence. Only one has to be present. And verb is also 2, that is greater than equal to 1. So at least one verb is there. Now you increment count. So count is incremented, that is we have found an ideal sentence. So count is now 1. S list, inside S list, we are appending what? W list. But is this append symbol?
No, ma'am.
We need two pluses.
Two
Double plus.
pluses we need. So 19 is also wrong. If I pick this also, I am having two pluses now. So now S list is a list of lists which contains what? The first list of words from the first ideal sentence. He likes running. All the words from this ideal sentence. This is one element of S list. After this, A, B, C all are reinitialized to 0 and W list is reinitialized to empty list because now we want next ideal sentence words being stored in W list, right? So at the end of every sentence. So another mistake is there. Now you have to spot that. So tell me what happens if my current sentence. So regardless of whether it is ideal or not, we are always storing the words in W list, right? At any point, we want W list to be storing the words of the current sentence that I'm reading. So what happens if my current sentence is not an ideal sentence? Then for the next sentence, I again need W list to be reinitialized to empty list. So is that going to happen here if my current sentence is not ideal?
No, ma'am, it is not
No.
happening.
Because see, we will only enter the nested if this condition is true, which is only going to be true for ideal sentences, right? And then W list is being reinitialized here. So W list should be reinitialized regardless of whether your sentence is ideal or not. So we should have this outside. That is, as soon as you reach the end of a sentence, it should be in the outer if, right? Here, after line 22, we should have this. So this is the third mistake. Any other mistakes you can spot? I don't think. Let's see. Let's see the options. Is the code clear for everyone?
Now, can you explain again the line 21?
See, W list at any point should contain what? The list of words of the current sentence I'm reading, right? At the end of a sentence, it should contain all the words from that sentence. So that means what? For every sentence, I need W list to be reinitialized to an empty list, right? But for such sentences which are not ideal sentences, will W list be reinitialized?
No.
Because the nested if condition will not be satisfied and it is inside the nested if. So it has to be outside the nested if. That is, every time we reach the end of a sentence, that is, outer if condition is true, the X word ends with a full stop. Then, regardless of whether your current sentence is perfect ideal sentence or not, W list will be reinitialized. So it should come here. W list is equal to empty list should come after line 22, after the closing brace of the nested if.
Ma'am,
Okay.
ma'am, the reinitialization of A, B, and C should also be outside of a nested if.
So, wait, your voice cut off. You tell me again, what did you say?
The reinitialization of A, B, and C should also be outside of a nested if because it is only reinitialized to 0 if the sentence is ideal.
Correct. So that's why I asked you that are there any other mistakes? So nobody said anything, but this is a good spot because this also has to be reinitialized for every sentence, right? Because we are checking the number of nouns, pronouns, and verb in every sentence individually. So whether or not it's an ideal sentence or not, both these things should be reinitialized. The ABC variables, the count of noun, verb, pronoun, and the W list itself. So both of these should be outside of this closing brace. The only thing inside the closing brace is this count and updating of the S list. Okay, because these two are dependent on the current sentence being ideal or not. The other two should happen regardless. So now, see, line 3 is saying incorrect initialization of S list and W list in line 3. Is this correct? Initialization is correct only. Nothing wrong there. Line 6, incorrect update of W list. Here. Is it incorrect?
No.
No,
No,
it's
it's
correct.
correct only. Line 17, incorrect if condition. Yes. So C is one of the correct options. D is line 19, invalid update of S list. Line 19, yes, because there was one plus was not present here. So this is also correct. Option E is line 20, misplaced reinitialization of A, B, and C. Correct. Outside of the brace it should be. And also this is correct, misplaced reinitialization of W list. That is these last two things that we discussed. ABC reinitialization, W list, this should come outside of this inner if. So option C, D, E, and F should be correct. Let's check once. C, D, E, F. Anyone has any doubt in this question?
No, ma'am.
Again, comprehension type question for this 6 to 8. So question 6 is for 4 marks. The given pseudocode is executed using scores dataset. At the end of execution of given pseudocode, choose the correct options. It is a multiple select question. Again, MSQ we have. Okay, so for scores dataset, topper is a variable inside which I am calling a procedure called find top, which takes table 1 as argument, that is the scores dataset itself. So here the control will shift to line 2, that is the definition of the procedure find top. Now in find top procedure, what happens? Max is a variable which is initialized to 0 and top is a variable which is an empty list. Now inside that we have while loop. So while table 1 has more rows, now inside this while we are just iterating through the entire scores data set, right? So every time you pick a card, you read it, then you have the if condition. If the total marks of that card is greater than max, then max is updated to that total and top variable, that is this empty list, is containing what? Sequence number of that card, comma max. It is an ordered pair of sequence number and maximum marks. So at the end of iteration, max should represent what?
Maximum marks.
Total maximum marks.
What happens if more than one person has maximum marks?
It
For
only
which
show
person?
one.
So the person whose card comes first,
Yes,
only
ma'am.
their marks will be stored because we don't have an equal to sign here, right? It's strictly greater than. So if someone's total is, let's say 300, which is the highest total, if someone card after that also has this 300 total, won't be satisfying the condition, right? 300 not greater than 300. So in this case, it will only capture the first highest mark. So max will contain the highest total and top will contain what? The sequence number of the person who has scored the highest total, whose sequence comes first in the ordering, right? And followed by the marks itself.
Ma'am, if there is greater than equal to sign, then the
Then the last
next
person,
one. Okay.
last one who has scored the highest. So now you can see the options and tell me which ones are correct. A is saying topper is a list of 2 elements. So
Correct.
topper is basically this one where we called this. So what is being returned? Top is being returned, which is a list of 2 elements. This top is going to be stored in topper. So A is correct, yes. B, first of topper represents the sequence number of one of the students who have scored the highest total mark. One of the students. First of topper is what? It will extract the sequence number. So is this correct or not?
Yes, ma'am, it is correct.
It is correct because more than one student can have the same highest total mark. So it will only capture the sequence number of one of the students. C is saying first of topper is the list of sequence numbers of students who have scored the highest total marks. First of topper, that means this X dot sequence number. Is it a list?
No, it's the element.
It's the single sequence number, right? So this is wrong. If we wanted to make it into a list, the next dot sequence number had to be initialized. The sequence number thing has to be initialized as a list, and then you add each of the sequence numbers who satisfy the criteria. D is saying last of topper is the highest total mark from table 1.
It is
This is
correct.
correct. This is correct. See the answers. A is true. B is true. C is no, not true. D is true. A, B, and D. Okay, I hope this is clear for everyone, right?
Ma'am, I have one question.
Hmm.
Like this is for 4 marks. So
Hmm.
how the marks are distributed for like choices? Like in the above
Uh,
one also that is 5 mark question. So like how we'll get if there
no,
are
see, the
four.
thing is, if you get one choice wrong, right? If you get one choice wrong, then the entire thing is wrong.
Oh,
But if you get like 2 choices right and no wrong choices, then you will get partial marks.
Okay.
Okay, but as soon as you enter a wrong choice, the entire marks goes to 0.
Hmm.
Okay. Question 7 is the same thing. Okay, just now we are adding some more things to that same code. So consider the procedure find top mentioned in question 6. So the following pseudocode is executed using scores dataset. Let remove row table Z deletes the row of table with sequence number Z. What will marked list represent at the end of execution of given code? Okay. See, in this question, we had this procedure find top. Right now, what this is saying is you consider that same procedure. Okay, now this pseudocode is executed on the scores dataset, and remove row is a procedure that takes a data set and the sequence number Z, okay, of any card, and it deletes the row with that sequence number. That means that particular student's all information is now gone from your scores dataset. Okay, what will marks list represent at the end of execution of given pseudocode? So in this pseudocode, we can see topper is an empty list, marks list is an empty list. Okay. So while table 1 has more rows, so in topper we are passing this procedure find top. So we have already seen what find top does. It will get you the sequence number of the first person to score the highest marks, highest total, and the highest total itself. Right, this pair we will get. Now we are calling remove row next, and we are passing the table 1 and first of topper. What is first of topper? The sequence number.
Sequence.
So what does remove row do? It will remove the information for this particular student in table 1. So let's take an example. Let's say in our table, a student with sequence number 8 had scored the highest total, that is 280. Again, student with sequence number 15 had the highest total, that is 280. Again, student with sequence number 24 had the highest total, 280. So they are coming in this order, let's say. Then when I call the find top procedure, whose sequence number will be stored?
8 wala. 8.
8. First
8.
one. So it will be 8 comma 280. Now remove row. You are passing table 1, and what is first of topper? 8. That means this person's information is now removed. Okay. And in marks list, what am I appending? Current topper. So marks list is containing what?
Total
It is a
marks.
list of lists containing current topper, which is 8 comma 280, right? Topper is containing 8 comma 280 only. Then we remove the row from the table. And now I'm appending the current topper into. Now go for the next iteration, because we will execute this until table 1 is exhausted. So now if table 1 started with 30 rows, now it has 29 rows because this row is removed. Next time when you call this find top again, in topper what will be stored? Now that this row is gone.
The next
Next
topper.
top marks.
That is 15 comma 280. Right? Again remove row. Whose row will be removed? This student, sequence number 15. This is removed. Now marks list will be appended with the current topper, that is it previously had 8 comma 280. Now it will have 15 comma 280 also. Next time you again call. So now your deck of cards has 28. Right? Next, in topper, what will be stored? The first 2 toppers are gone. What is the highest
Third
marks now?
topper.
Next.
Third topper,
24.
24 to
280.
Again, their row will be removed. In ML, we are again going to store them. 24 to 80. Okay. So now all the highest marks are gone from your data set, but will the iteration stop? Now your
No, ma'am.
database still has 27
No.
cards left. So we will again iterate. Now let's say the second highest in class is scored by some student with sequence number 7. They have scored, let's say 275, which is the second highest. So now they will come in marks list, right? They will become the next topper. Then their card will again be removed. Sequence number 7, 725, 7275. This row will be now removed from the data set. They will also be added to marks list. Like this, we are going to be eliminating every single topper. Until when? Until we have no more cards left in the deck, in our deck. So marks list is what? It is a list of lists, right? List of ordered pairs of what? Sequence number and
Descending
highest
order.
mark. In descending order of what? Total marks.
Marks. Total marks.
So now check the option. What is marks list representing?
Option number
First two
C.
options we can eliminate because it is not list of sequence numbers. It is a list of lists, a list of ordered pairs. So option C is saying list of pairs of sequence numbers and total marks in descending order based on the total marks. This is correct. It is not in ascending order. This one is clear for everyone? Any doubt? Okay. Question 8. Consider marks list created in question 7. So again, it is a part question. Right now we have marks list created. We know what marks list is. What will top list represent at the end of execution of the pseudocode? So now you're executing this one. So top list starts off as an empty list. Okay, and counter is a variable which stores 1 initially. In max variable, you're storing what? First of marks list, first you extract that, then last of that. Okay, let's come to our marks list. What is the first of marks list here?
List of highest mark with sequence number. Sequence number with
What?
highest marks.
Just give me the element.
8,280.
8,280. What is last of this element?
280.
280. So that is being extracted here. Max is containing what? Last of first of marks is. That is the highest total marks, right? In the entire data set. Now, for each pair in marks list, that is each of the elements in marks list, if last of pair is not equal to max, that means for every pair is what? Sequence number, comma, total marks. For every such pair, if the total mark, that is last of pair means the second element, that is the total mark, is not equal to max. In our example, if total marks is not equal to 280, then max will store what? Last of pairs. Okay, let's see our example. For which element in our example, let's say there are more elements here. For which element in our example, this condition will be valid, that last of pairs not equal to 280.
275.
This one, right? 7,275. 275 not equals to 280. This is the first one. So now max will become what? Last of the current pair. So max becomes 275. Counter becomes incremented by 1. Counter started at 1, now counter is 2. Okay. Like this, we will go through every such pair. Okay, let's say there are other pairs also in our marks list. Let's add some pairs. Maybe 3,275 and then 11,270, 22,260. Okay, these are all in descending order. So now my current max is 275. So for this pair, will max update for 3,275? See, my current
Yes, ma'am.
max right now 275. Okay. Now for next iteration, will this pair update max 3,275?
No.
No.
Which pair will update? This one, 11,270.
Yes, ma'am.
270
Yes.
not equal to 275. So now new max is what? 270.
270.
So as soon as I find a new max, update it 270. Counter is what? Updated again to 3. Okay. See, this last one we are not doing, right? I'm just trying to explain what is the first if do. What does the first if do first? But now we got the hang of it. What is the first if doing? Now let's see it with the second if. So firstly, we started with max 280, right? When it reached, let's say, first card we picked is 8,280 with pairs, right? For this, no changes happened in maths. But when I come to this if will execute, right? Because counter started with 1 less than 4. See again. It will be better if I just write this here. Okay, we don't have to keep scrolling. So this is my marks list. Contains elements 8, 280, 15, 280, 24, 280. What else did I have? 7, 275.
11, 260.
I had one more 275, sequence number 3. Then we have 11, 260, and I have 22, let's say 11, 270, and I have 22, let's say 265. Okay, let's say this is our marks. There are more elements, obviously. Okay, now let's try to, someone else?
Yeah, actually I said top list will add all the sequence number of top three marks.
Correct. Let's go through this. Okay. For each pair in marks list, what is first pair? This. What is max? Currently 280. Last of first pair and max, are they equal? 280, 280? Yes.
Yes.
So max will not be updated. Counter will also not be updated. So come here in the second bit. Counter is less than 4. Counter started with 1. Yes, 1 less than 4. So top
Yes.
list will contain what? First of pair. What is first of pair? 8.
Sequence number.
So top list now contains 8. Go for the next one. Here also max will not be updated, same 280. But counter remains 1. So 15 will be added to top list. Similarly, 24 will be added to top list. As soon as I come to this pair, now 275 is not equal to current max. So this it now works. Max is updated to 275. Counter becomes what? 2. 2 is still less than 4. So first of pair will be appended to top list. That is 7 will be appended to top list. Again, 3 will be appended to top list. When I come to this pair, 11, 270. Now 270 not equal to 275. Again, max is updated to 270. Counter is updated to 3. 3 is still less than 4. So first of pair 11 is going to be added to top list. Next item when you come to 265, max is again updated to 265. Every time we find a lower max or different max, we are going to update. Counter is now 4. But 4 less than 4 is violation of this if condition. So will there be any more additions to top list?
No.
No.
We stop here. So who are these people? These are the people who have scored the first 4 highest marks. Right. Top 4 highest marks. 270, 275, top 3 highest marks. 270, 275, 280. As soon as we come to the 4th highest marks, counter is becoming 4, so we cannot add any more IDs to top list. So which option correctly depicts it? First one is saying
Option
list.
A.
Option A is saying list of sequence number of students whose total marks is in the top 3 total marks. Okay. This seems to be correct. Let's still see all of the others. List of sequence numbers of 3 students. Definitely not. There can be as many students among the top 3 total marks. Option C is saying list of pairs. It is not a list of pairs. So C and D are auto eliminated. So option A is correct. Let's still check once. It's option A. This is clear for everyone?
Yes, ma'am.
Okay. Next question. Question 9. Following pseudocode is executed using scores dataset. 2 students are called similar. So who are similar students here? If their difference in maths mark is at most 10. At most means what symbol?
1 to 10. 1 to 10.
10 or less than 10.
That
Less
means
than or
if
equal
x has to be at most 10, that means x should be less than equal to
Less
10.
than and greater.
Correct. Okay. So two students are going to be called similar students if the difference in math marks is at most 10. So let absolute C return the absolute value of integer C. That means if you give plus or minus for any number, absolute value just gives you the mod value, right? Without any symbol. So triple list is initially empty. It is asking what will triple list represent at the end of execution. Okay. Initially triple list is empty list. Now, while table 1 has more rows, okay, let's again number the braces. First opening brace, second opening brace, third opening brace, fourth opening brace, fifth opening brace. Now fifth brace is closing here, fourth brace is closing here, third brace closes here, second brace closes here, first brace closes here. Okay. So whole thing is inside. No, I think yeah, okay. So whole thing is inside the outer while. So there are two while loops here, right? One nested while is here on line 5. Now let's see what it is doing. So we have to read the first row in table 1 again sports data set, same data. So you pick up one card in the outer while loop. Now you come to inner while. Again pick another card. So now I have two cards X and Y. I'm going to compare their marks, right? So if absolute value of X math minus Y math. Why am I taking absolute value?
Because we are
Because we have
comparing
to want
difference.
positive.
Right, because we are basically taking a difference of their maths marks, but depending on who has scored the lower marks, the difference might be negative. Right. Like if if X has scored 40 and Y has scored 60, then 40 minus 60 will give minus 20, but I need the absolute difference, which is 20. Okay, so regardless of the order in which I do the subtraction, that is X from Y or Y from X, the difference will remain same. So I am just using the absolute function for that. So if absolute value of their difference is less than equal to 10, less than equal to is correct, we want at most. In that case, I will enter the nested if part, which is another while loop. So now you pick one more card, that is row Z. Okay, one more card you have picked. Again, check the absolute difference. Absolute difference of X and Z. So now first card was X, second card was Y, third card was Z. We have established that X and Y are similar students, right? Because their absolute value is at most 10. Now I have entered another nested while where I have picked up the card Z. Now I am checking if X and Z are similar. So if absolute value of the difference of X and Z maths marks is at most 10 and Y and Z maths marks is also at most 10. That means I'm trying to check if X, Z are similar and Y, Z are similar. If this is also true, then triple list will be appended with sequence number of X, Y, and Z inside a list. So triple list, can I say it is a list of lists?
Yes.
What can I say about triple list? Every element is what in triple list?
Sequence number.
In triple
Sequence.
list, every element is a list containing 3 sequence numbers who are all similar among themselves. Like X, Y are similar, Y, Z are similar, X, Z are similar. See, every time we are done comparing with this Z, we are going to move Z to table 4. Then we remove all rows from table 4 and bring them back to table 1. Okay, this happens when after you close this inner while, innermost while. So that's why I numbered the braces. Here the innermost while opened, right? So once this if block brace number 5 is closed, you move your current Z from move your current Z to table 4. Then once we have checked for all the Z values, we are going to close this innermost while at brace 4 and remove all rows from table 4 back to table 1. So that we are going, our job is what? We want to compare among all combinations of cards, right? So we started with X and Y. See, once X is read, it is sent to table 2. Once Y is read, it is sent to table 3. Okay. So for every Y iteration, we are going to pick a card from table 1. So whatever we have picked from table 1 is not going to be duplicated. Once it is sent to table 2, nothing is recovered from table 2. See, we move all rows from table 4 to table 1 and rows from table 3 to table 1. That means X values are not going to be repeated, right? Every x I pick, I'm just going to find every possible yz triplet along with it. But then the yz values have to be again brought back into the original table, because next I have to check for those values also. But the x is never repeated. So where is the duplication cutoff? Here, where we move x to table 2. So every time the x card is moved to table 2, that is never recovered, right? But we have to find every possible yz combination for x. So every yz value, when we are reading them, they are being moved. See, once I read y, it is being moved to table 3. Once I read z, it is being moved to table 4. But these values again need to be checked for other triplets, right? For x, I have found all possible triplets with yz values. But for yz, these values also I need to find all possible triplets. So they will be recovered back to table 1 after every outer while iteration is ending. Okay, now you understand what is triple list containing. It is a list of three. Basically, triple list is a list of lists where each list or each element contains three sequence numbers who are all similar students among themselves. So which of these is correct? Triple list is representing what? List of lists of sequence numbers of similar students. Okay. First, tell me this. List of pairs of sequence numbers of similar students, is that triple list?
No, pairs is 2.
There are three elements in each of the lists. So this is definitely wrong. This one is saying option C, list of triples of sequence number of similar students. Is this correct? Or is this correct? List of lists of sequence numbers of similar students. Option
Yes.
C is the correct one. See, when I say triples, it already means it's a list. Triples form a list. But when I say lists of sequence numbers of similar students, there can be any number of similar students in every list, right? But in our case, every inner list should contain exactly 3. That is, it should be a triplet. If I take the first option, then lists of sequence numbers of similar students would mean that every list contains maybe 4 students, X, Y, Z, P, or 5 students, whatever it is. But we want triplets. So list of triples of sequence numbers of similar students. Option C. Is it clear why this option is not correct? A.
Yeah.
The entire question is clear. Anyone has a doubt?
Ma'am, this moving to table, this is not very clear.
Look, you have to understand it this way, that for every X that I pick, right, I have to check all YZ combinations. For every X, I'm checking all YZ combinations. That means, okay, for example, let's say my X is 60. For that, I found a Y which is 65 and a Z which is 68. Are these three similar? Their difference in maths marks is less than equal to 10. XY similar, YZ similar, XZ similar. All
Yes.
differences are less than equal to 10. So
Yes.
they can form a triplet. Now for this particular X value, I'm going to find all such YZ pairs that exist. Okay, which can form such a triplet. Once that is done, then I know that for this X value, it is exhausted. That means this X card can be totally removed from my deck of cards in table 1. But have I checked individually for this Y value or this Z value? No. They have only appeared once, right? But again, if I take X as 65, I might find a different Y, let's say 74, and a different Z, let's say 69.
Yes, ma'am.
I'm sorry, not 69 will not work. Wait, yeah, 69 will also work, yes. So they can also form a pair, right? So I cannot discard this Y or this Z. So every YZ value for every X value have to be recovered for the next iteration. But the X value is completely exhausted. So you can move it to a separate table, table 2.
Okay.
Understood?
Okay.
Okay. Yeah, that's the last one. Okay, so practice assignment. Any doubt in any of the questions?
Ma'am,
I
please
can't
share this PDF.
understand last question.
Which part? Tell me. Which part you didn't understand?
It's too much confusing. I'm confused totally.
Okay. Okay, let me start from the first. Okay. Yeah, I'll share this PDF with you. If others don't have any doubts, you can leave. Okay. See, here we are trying to find similar students. Okay, similarity is based on a criteria, that is their difference in maths marks is at most 10. That is less than equal to 10. Fine. Two
Yes.
students are similar when their maths mark difference is at most 10. So if I say x is 60 and y is 65, this is their maths mark. Are they similar? Can I say x and y are similar?
No, madam.
Why not? X has 60 marks in maths, y has 65 marks in maths. What is the difference? Absolute value of difference is what? 60 minus 65 mod.
Five.
It is 5. Is 5 less than equal to 10?
Yes, ma'am.
Yes, ma'am.
So they are similar. X and y are similar. What we are trying to see is what is triple list going to represent at the end of the sentence? Okay. Look. These are just the braces I have marked, right? Opening and closing. So first, triple list is an empty list. We have to figure out what is triple list representing at the end of execution. Now, while loop, there is an outer while, there is an inner while, there is a third inner while. Okay. So what is happening? First, I'm picking one card X from table 1. Table 1 is a sports data set. Let's say that card has maths marks 60. Okay. Now you enter the nested while, line 5. Pick another card Y. Let's say Y is 65. Okay. As soon as you read X, you move it to table 2. So table 2 now has this card X60. As soon as you read Y, you move it to table 3. So table 3 has card Y is equal to 65. Now you check if absolute value of the difference of their maths marks is at most 10. What is the difference of their maths marks? 5. Absolute value. That is, signs don't matter, positive or negative, just the magnitude. So is this condition correct? If condition is correct? Yes, no. What is the if condition? Is it correct? Who asked this question?
Yes, ma'am.
Tell me, is this correct? The if condition in line 9 for these xy values. Is 5 less than equal to 10?
Yes, ma'am.
Yes.
It's
That means the if condition is correct. So I can come inside the if block. Now there is a third nested while. So here you pick one more card. Read the first row Z in table 1. So you have one more table to maintain, that is table 4. Let's say the Z value you read here is 69. Okay. So read the first row in table 1. Now you are checking if absolute value of x minus z is less than equal to 10. What is x minus z? 60 minus 69 is? Mod value is 9.
nine.
Absolute value. It is less than equal to 10. So fine. And what is y minus z? 65 minus 69? Minus 4, but mod value is 4, which is also less than equal to 10. So both conditions satisfy.
Yes, ma'am.
So you can again enter this if block. What am I doing? Triple list, this empty list. Inside that, I am appending this as an element. What is this element? This is x, y, z. X, y, z is the sequence number. Okay. But Triple list is a list of lists because we are appending this element in the form of a list. See, there are double third brackets. That means this is a list itself, right? So every element in triple list is of this form, a single list of three sequence numbers. What are these sequence numbers representing? These three students are similar students among one another, right? X, Y are similar, X, Z are similar, Y, Z are similar. We have checked all three conditions in the if statements, right? So like this, we will find every such XYZ combination and add it to triple list. So triple list will become a list of lists where there are combinations like this X1, Y1, Z1. There might be another X2, Y2, Z2, whatever. Just unique combinations of sequence numbers who are similar students. That is, among these three people in a list, every pair is similar. XY is similar student, YZ is similar student, XZ is similar student. So now you are being asked what is triple list representing. So triple list is a list of triples. That is, every element is a triple. A list of three elements is called a triple. So if the triple list is nothing but a list of triples of sequence numbers of similar students. Is it clear?
Yes, ma'am. Now it's clear.
Okay, just do a dry run of this with a few values from the data set and it will become more clear. Okay, anyone has any more doubt in this practice assignment?
Ma'am, apart from the practice assignment, may I ask
Yeah.
another question, please?
Hmm.
Ma'am, actually, I got little confused in the flag when flag initiated true and then the condition given uh, flag in bracket or not flag in bracket and
Yeah, okay.
like this if flag initiated to true and then if flag or if not flag. What is the difference between these things?
Look, if flag is true, right? That means flag is what type of variable? Boolean. It can take true or false value.
Yes, ma'am.
After this, if I say if flag, okay, if flag, and then I open the braces and there are some statements. Let's say I am incrementing some counter, count equals to count plus 1. So when will this count equals to count plus 1? When will this increment happen? If flag is true. That means if true, then you do this. But somehow if flag was false, then I cannot increment because if false, that means you are violating the if condition, you cannot enter the if block. Okay, just for flag, this is true. Now if I write if not flag, okay, and I have the same count is equal to count plus 1. Now if you tell me if flag is true, what is not of true?
False.
False. That means the whole thing will evaluate to false. So you won't be able to enter the if block. But if flag is false, then not of false is true. Complement of false, not of false, is true. So now you can enter the if block and increment the count. So depending on what is your flag value, always remember you can only enter the if block if the entire expression evaluates to true, whether it is flag or not flag.
If flag is initiated to false and if in
Then if you
brackets,
have if flag,
okay.
right? If flag is initiated to false and you have this expression if flag, that means you cannot enter the if block until and unless flag becomes true again.
True.
But
Okay.
if it is initialized to false and you have the expression not flag, then this is true. Not of false is true.
Okay. Then I will enter this block when flag will be true.
Flag will be true. That is for this one. Okay. And this one you will enter when flag is false. Not of false is true.
Just one thing. If flag is initiated to false and if not flag is given, that means ki if not false, that means true.
Yeah. Then you can enter.
Okay. Thank you. Thank you so much, ma'am.
Ma'am, can I ask one thing, like practically, not related directly to any question?
Yeah. Ask.
So, like, ma'am, these all the content is on the screen, and like when you are explaining, you are able to write right next to the sequence and like next to the pseudocode, and then you can. But For like if thing is on screen and if we are doing on the paper, it gets a little like then how to approach?
Uh, See, of course, you will not have it like this, right? So you have to write on paper. So basically, what you can do is you can understand how the code is working. Keep that in mind, and then you just do the dry run on your paper. I mean, you will have the code open. You can obviously always refer to it, but do the dry run on the paper. That is, just write down this is first iteration. What am I doing? Or you can just write one instance of the code in your paper if you have the time. If it is not a huge code, you can just write 4 5 lines of the code on your paper, then it becomes easier to do the dry run. You don't have to keep switching between screen and paper, right?
Yes, ma'am.
But if it is a large code, then first understand what each of the segment is doing. Always break it down into segments.
Okay. Because like the thing is if we write on paper, then we forget which line and where it was
Exactly. That's why if it is a small code, you can just write the instance on paper. But if it is large, then you do each of the segments different way. Okay. First do each of the segments, then you combine the whole thing.
Okay.
In CT, we won't give you much very big codes. Okay. It will be as long as you can see in the graded practice assignment. That is the highest we will go. Okay. Nothing more difficult than that.
And ma'am, like how to take cases also, because which case will like we get lost in a lot of cases because we are unable to understand which case to
Hmm.
take for dry run.
So see, for words data set, like I said, words data set, you can take any sentence, okay, because mostly the part of speech doesn't matter. But if in a question it is given, like today's question we did one verb and one noun, you just try to form a sentence of that. Like I did, he likes running. Here I have one verb, one pronoun. Okay, so in specific cases, you have to build the test cases in your head. That nobody can help you with. Test cases, you have to understand what is my correct test case I can use on a particular problem because test cases differ for every problem, right?
Yes,
So
ma'am.
to understand what is the correct test case, first you have to understand what is the code doing. Okay. First decode what is the job of the code. Then I run a test case on it. And if you cannot at all understand what the code is doing, then start with a random test case. Like in scores data set, start with any student. Okay. But mostly you will be able to decode what it is doing.
Yeah, ma'am. Like it needs practice for sure.
Yeah, definitely.
Yeah. Thank you so much, ma'am.
Okay. Okay. Yeah. Thanks everyone. Thanks for joining. Also join tomorrow's class. Okay. You can leave. Have a good night.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
हेलो। हेलो।
Does anybody have any idea like how to see this lecture recorded?
Can you speak slowly? What do you say?
I'm asking how to see this meeting which happened right now, how to see the recorded version of this.
Okay. May I speak in Hindi language?
Yeah, sure.
ओके। तो वो जब मैम आएंगी तो वो लिंक दे देंगी ना तुम्हें?
अरे नहीं, यहाँ पे जो कैलेंडर पे दिखाया है ना उन्होंने, तो वहाँ पे क्या है कि एक मीटिंग का उन्होंने लिंक दिया हुआ है और एक यूट्यूब का लिंक दिया हुआ है। तो मैं जब यूट्यूब के लिंक पे क्लिक किया ना, तो वहाँ पे 2 हफ्ते पुराना कंटेंट दिख रहा है। हेलो, यू आर नॉट ऑडिबल।
हेलो, अब सुनाई दे रहा है? हेलो।
हेलो,
हाँ। तो एक मिनट, लिंक तुमको कहाँ से मिली?
अरे ऐड कैलेंडर वाला ऑप्शन है ना, वहाँ पे आज के डेट पे जो सारे लाइव लेक्चर्स हो रहे हैं उनके लिंक होते हैं ना,
हाँ।
तो वहाँ पे
ओके।
यूट्यूब का भी लिंक था ये सेम लेक्चर का। उन्होंने यूट्यूब पे जो होता है उसका लिंक दिया हुआ है, तो उस पे नहीं दिख रहा है ये सेम लेक्चर रिकॉर्डेड, कोई और ही लेक्चर दिख
ओके।
रहा है उधर।
ओके, लेट मी चेक। ये 2 वीक, हाँ यार, ये
2 हफ्ते
2 वीक
पुराना
पहले
है।
गए हैं। हाँ।
और
नहीं तो।
ऐसे बहुत सारे उस पे कैलेंडर
हाँ।
पे बहुत सारे ऐसे लेक्चर्स है, टीए सेशंस, जिसके यूट्यूब के लिंक ही नहीं दिए हुए हैं, तो उनको कैसे एक्सेस करना है?
आ,
पता नहीं कौन सा लेक्चर कहाँ पे है, क्या है, पता नहीं, समझ में नहीं आ रहा।
तो मैं बताऊं, देखो, यूट्यूब ओपन,
ओके,
IITM BS क्वालिफायर लाइव, ऐसे ये कीवर्ड डालो। लाइव सेशन, IITM BS क्वालिफायर लाइव सेशन, ऐसे कुछ लिख के कीवर्ड आ गया होगा। देन क्लिक इट।
लाइक।
ठीक है। अरे यार।
तो उनका जो
ओके,
ये चैनल है
ऑफिशियल
ना,
पे
मेन
जाओ।
चैनल।
सॉरी सॉरी सॉरी, वेट वेट, लिसन लिसन मी, लिसन लिसन लिसन। हेलो।
हाँ हाँ, हाँ हाँ।
हाँ, उसकी ऑफिशियल डिग्री पे गई जिसपे 5.71 सब्सक्राइबर हैं। 5.17
फाइव
के सब्सक्राइबर हैं।
मुझे जो दिख रहा है उस पे तो ये है 2.4 lakhs, 2.14।
अच्छा, तो अच्छा, @DBMS IIT मद्रास डिग्री 1439।
वन।
कीवर्ड मतलब ये टाइप करने पर आ जाएगा ना, सर्च में लिखो @DBMS, फिर हाइफन
हाँ
का
हाँ,
माइनस का, है ना?
एक
फिर
मिनट आ गया शायद।
IITM, कितने सब्सक्राइबर? 5.
डेटाबेस, अरे वो तो डेटाबेस मैनेजमेंट सिस्टम का कुछ तो चैनल है। ये भी वही है यार, ये 5 पॉइंट कौन सा चैनल बोल रहे हो तुम? अच्छा, 5.17 के। ओके ओके, हाँ हाँ। पर ये तो डीबीएमएस करके चैनल है।
डाटा, अच्छा, MS का है क्या ये? नहीं, वेट यार, तो उस पे वेट, तो एक मिनट, बस एक मिनट। हाँ, ये तो अपना ही सिलेबस है ना।
ये अपना वाला ही है क्या?
सुपर की अपने सिलेबस में है क्या?
वीक 5
हाँ,
लाइव, शायद अपना ही है ये।
ये अपना में नहीं है, ये अपना का ये डिग्री का सिलेबस है क्या? एमएस का सिलेबस है क्या?
एक मिनट देखिए,
वीक 3
आईआईटी
लाइव
मद्रास
सेशन।
बीएस डिग्री।
हाँ ये
अरे ये
अपने, हाँ ये,
डेटाबेस
हाँ ये तो अपना नहीं है यार।
अपना नहीं है ये।
हाँ एक मिनट, ऑफिशियल पे जाके फिर लाइव पे जाओ, देखो वहीं पे मिल जाएगा। ऐसे ही मैंने एक बार सर्च किया था, आ गया था।
ऑफिशियल पे ना ये वाले नहीं है यार, ये जो टीए सेशंस हो रहे हैं ना रेगुलरली, ये नहीं आ रहे हैं ऑफिशियल पे। आज का भी पता नहीं, आज का मुझे देखना था पर मैं ये लाइव नहीं देख पाई नाम का, पर यूट्यूब पे आना चाहिए। हेलो। हेलो।
हेलो वैष्णवी।
हाँ हाँ।
मतलब हम तो इसमें अकेले हैं क्या, मतलब मीटिंग में?
हाँ शायद हम दोनों ही हैं।
तो कितनी देर से तुम यहाँ पे हो?
अरे मैंने अभी ज्वाइन किया है जस्ट, और मुझे अभी पता चला कि एक सेशन हो चुका है, तो मैंने फिर मुझे पता चला कि यूट्यूब का लिंक गलत है, इसलिए मैं पूछ रही हूँ यहाँ पे।
नहीं तो कौन सा सेशन हो चुका है?
ये कंप्यूटेशनल थिंकिंग का।
अच्छा हो चुका है, तो मैम तो इसको ओपन क्यों किए हुए हैं?
पता नहीं, जस्ट अभी खत्म हुआ है, जस्ट अभी थोड़ी देर पहले खत्म हुआ है, पता नहीं ओपन क्यों है ये। तुमको पता है क्या कैसे एक्सेस करना है उसको?
हाँ पता, मैं एक्सेस अभी कर दूंगा थोड़ी देर में, लेकिन लिंक कैसे शेयर करूँ तुम्हारे पास?
इस पे चैट का ऑप्शन है ना, इस पे कर सकते हो।
इस पे ओपन नहीं हो रहा है मेरा हाँ ओपन है, ओके ओके ठीक है। इस पे ऑनलाइन रहना, ठीक है, ओके हाँ, ओके।
हम्म।
आई एम जस्ट ट्राई, और अगर होगा तो मैं भी शेयर कर दूंगा, लेकिन वैसे लाइव सेशन 2.4 computational thinking videos live upcoming live development tactics। 2 days एगो तक है। हेलो।
हाँ वही देख रही हूँ मैं, उनके ऑफिशियल वेबसाइट पे 2 दिन पुराने तक तो है। आज भी मॉर्निंग में इसका स्टैटिस्टिक्स का 10 बजे हुआ था, उसका भी नहीं है वीडियो।
हाँ सबसे जो फास्ट रहता है वो जो मैम कराती है मैथ का, उनका रहता है ना?
इसीलिए तो बोल रही हूँ मैं, क्योंकि मैं सर के नहीं देख पाऊंगी यार, वीडियोस उनके बहुत स्लो है।
क्या क्या नहीं देख पाओगी?
सर के जो रिकॉर्डेड वीडियोस है ना, प्रोफेसर नीलेश के, जो नीलेश
हाँ
सर है, जो मैथ्स पढ़ा
हाँ
रहे हैं, उनके बहुत
हाँ
मुझे स्लो
हाँ।
लग रहे हैं। इसलिए आई थॉट कि मैं सिर्फ टीए सेशंस ही करूंगी, बट टीए सेशंस भी प्रॉपरली कहाँ दिख रहा है यहाँ पे? टीए सेशंस का यूट्यूब लिंक भी इन्होंने प्रोवाइड नहीं किया हुआ है, ऑफिशियल वेबसाइट पे जो दिख रहा है वो सारे नहीं है इस पे।
अच्छा जो मुकुंद सर है ना, मुकुंद करके सर है ना, मतलब सीटी का?
सीटी का नहीं, मैं भी मैथ्स की बात कर रही हूँ, सीटी का तो छोड़ो, सीटी का तो मिल ही नहीं रहा, पर मैं मैथ्स की बात कर रही हूँ कि
अच्छा
मैथ्स में सर का प्रॉब्लम।
मुझे तो मैथ में मतलब रिकॉर्डेड लेक्चर ज्यादा बेटर लगते हैं मुझे, तो मैथ में टीचर कंफ्यूज जाता है और टाइम बड़ा वेस्ट होता है, क्योंकि वो स्टूडेंट ही तो रहती है ना।
तुम कौन सी बात कर रहे हो, जो उनके जो
मैथ
रिकॉर्डेड
की,
लेक्चर्स हैं
मैथ
मैथ्स में?
की
वही
हम,
जो
मैं कह
प्रोफेसर
रहा हूँ
के
जो,
लिखने से हो।
मैं कह रहा हूँ कि जो मैम कराती है लेक्चर, जो मैम कराती है ये लाइव सेशन कराती हैं,
हम्म हम्म।
उसमें उसमें मुझे मतलब बहुत कम समझ में आता है। पहली बात मुझे कम समझ आता है, दूसरी बात उसमें टाइम बहुत ज्यादा कंज्यूम होता है।
मैंने मैम का नहीं देखा है, पर मैं जो मैंने कंप्यूटेशन थिंकिंग का देखा ना, वो मुझे मैम का अच्छा लगा था। शुरुआत में मैंने 20 मिनट तक किया, बट फिर उसके बाद नहीं कर पाई मैं। तो मैंने सोचा कि इसका चलो रिकॉर्डेड देख लूंगी बाद में, पर रिकॉर्डेड तो दिख ही
अरे
नहीं रहा ना।
यार मैं सीटी का नहीं बात कर रहा हूँ, सीटी की दुआएं तो बहुत अच्छी हैं, सीटी की दुआएं बहुत अच्छी हैं, बट सीटी का मौका ही नहीं मिलता, मतलब मैथ के आगे मौका ही नहीं मिलता सीटी का देखने का। सीटी की बात नहीं कर रहा मैं, मैथ की बात कर रहा।
ठीक है,
अंकित सर,
मैथ्स का भी। हाँ, मैथ्स का मैंने नहीं किया अभी तक मैथ्स का। चलो,
अभी
क्योंकि
तक
मुझे
आज
वो
तक लाइव
सबका
सेशन किया ही नहीं।
नहीं, लाइव सेशन मैंने कोई भी नहीं किया मैथ्स का।
पहली बार आई हो इसलिए इसलिए मतलब ऐसे, हाँ ठीक है।
बाप रे।
अच्छा एक बार एक क्वेरी और थी मेरी कि हेलो,
हाँ, बोलो।
जो अच्छा जो इंग्लिश में है, इंग्लिश में पहले जो कोर्स चेकर है ना, उस पे तो कुछ और दिखाता है, और जो डैशबोर्ड है उस पे कुछ और दिखाता है ना।
क्या चीज,
क्विज
कौन सा?
क्विज जो क्विज जो क्विज वन दिया था कि नहीं दिया था?
दिया था ना, ऑफ कोर्स, वाली
हाँ तो
क्वालिफायर।
हाँ क्वालिफायर। तो इंग्लिश में जो उसमें है, तो इंग्लिश में वो जो मार्क्स हैं वो, जो क्विज चेकर है, जो ना क्विज चेकर के जो ऑप्शन में आता है, उस पर अलग एक एक्सटर्नल वेबसाइट होती है, उस पर जाके चेक करना पड़ता है ना मार्क्स।
कौन सी बात कर रहे हो तुम?
यार
क्विज?
क्विज वन तो
भाई, मैं सिर्फ ग्रेडेड असाइनमेंट देखती हूँ। मैं सिर्फ उन्होंने जितने रिकॉर्डेड लेक्चर्स प्रोवाइड करे हैं वो सब देखती हूँ, और सिर्फ एक क्वालिफाई दिया है। मुझको बस इतना ही पता है, ज्यादा नहीं पता है मुझे।
सेम वही बात, क्वालिफायर दिया है ना, क्वालिफायर का रिजल्ट कैसे चेक किया?
रिजल्ट तो क्या, रिजल्ट तो उधर डैशबोर्ड पे दिखता है ना भाई।
तो डैशबोर्ड के अलावा एक क्विज करके ऑप्शन होता, मतलब एक एक्सटर्नल वेबसाइट होती है जिसपे वो कहते हैं कि चेक कर लो अपना।
नहीं, वो नहीं पता, मैंने डायरेक्टली डैशबोर्ड पे देखा था।
अच्छा इंग्लिश में कितने मार्क्स आए हैं?
इंग्लिश में 77।
अब देखना डैशबोर्ड पे, जो 77 का हाफ होगा तुम्हारा,
क्यों?
देख लेना चाहे वो क्यों होता है। देखो डैशबोर्ड चेक करो, इंग्लिश में देखना।
एक मिनट।
ई-
तुम तो लाइव कर रहे हो ना सारा टाइम?
हाँ
सीटी के कितने करे, सारे करे अब तक?
सीटी के ही नहीं किए, बाकी सबका किया है, सीटी और इंग्लिश के नहीं किया, बाकी सबका किया। एक देखो
तो
सर,
उनके
हाँ हाँ सर,
तो
एक्चुअली
उनके
वो
तुमको पता
ओवरलैप
है
हो जाते हैं ना,
रिकॉर्डेड?
मैं क्या करूँ ओवरलैप हो जाते हैं।
अच्छा।
हाँ अब ओवरलैप कर देते हैं तो उसमें क्या ही किया जा सकता है। दूसरी बात है कि यार मैथ से सबसे ज्यादा डर लगता है, बिकॉज मैं बायो बैकग्राउंड से हूँ ना।
अच्छा।
अभी मैं वीक फिफ्थ का इसे यूट्यूब से देख रहा था, यूट्यूब से पढ़ के फिर समझ में आता है यार। और जो जो
मेरे
हिंदी वाले
तो
टीचर है ना।
हाफ नहीं है। तुम्हारे
क्या?
क्यों हाफ हो गए मार्क्स? मेरे मेरे तो 77 ही दिख रहे हैं।
अच्छा डैशबोर्ड पे
हाँ, डैशबोर्ड पे।
तो केवल दिल्ली वालों के ही हाफ हुए हैं क्या?
हाफ क्यों होंगे?
हाफ हो गए हैं, हम लोगों के हाफ हो गए हैं। जो डैशबोर्ड में मान ली 77 दिखा रहा है, तो उसका हाफ डैशबोर्ड में दिखा रहा है। मतलब जो उसमें एक करके क्विज कर, देखो एक क्विज करके देखो, इस पे चेक करना अपने मार्क्स, देखो इस पे। और वीक फोर का अभी असाइनमेंट ही नहीं दिखा रहा हम लोगों को।
अच्छा। वीक फोर
हाँ
का असाइनमेंट नहीं दिखा रहा है मतलब?
हाँ, वीक वीक फोर का असाइनमेंट स्कोर ही नहीं इंग्लिश का दिखा रहा है।
अच्छा, एक मिनट, हाँ एक मिनट रुकना।
हाँ
लगी है मुझे तो ये सिस्टम ही समझने में बहुत टाइम लगेगा।
क्या?
ये इनका पूरा सिस्टम कैसे क्या कर रहे हैं, कहाँ पे कौन से कोर्सेज दिख रहे हैं, ये सब समझने में मेरे को बहुत टाइम लगने वाला है अभी।
यार इसमें तुम लैपटॉप पे एक्सेस करती हो कि किस पे एक्सेस करती हो, मोबाइल फोन पे?
लैपटॉप लैपटॉप पे ही करती हूँ यार।
हाँ
पर मैं
तो देखो,
लाइव।
सुनो बताऊं, सुनो इसमें एक और प्रॉब्लम, अच्छा तुम अभी क्वालिफायर, इसमें एक और प्रॉब्लम है जानते हो क्या? जैसे कि तुम्हें हर बार साइन इन करना पड़ेगा। ये बहुत बहुत
एग्जैक्टली
गंदी,
भाई, कसम से
बहुत गंदी, मैं पता है देखो,
हर बार
जो,
sign-in।
हाँ जो हो देखो, जैसे वो जो थ्री डॉट होते हैं ना लैपटॉप में, राइट कॉर्नर पे अबव जाओगी तो थ्री डॉट होते हैं, उसके बाद एक शेयर का ऑप्शन आता है सेटिंग के आसपास, है ना?
हम्म,
उस शेयर के आसपास मतलब जैसे यूट्यूब डेस्कटॉप डेस्कटॉप पर इंस्टॉल हो जाता
हम्म,
है ना, वेब वेब मतलब वेब खुल जाता है उसमें, ऐसे ही वो साइट
हाँ
इंस्टॉल करो डेस्कटॉप पर, और जैसे सिंगल क्लिक करोगी तो सीधा तुम डैशबोर्ड पे आ जाओगी।
ओके, हाँ वो शॉर्टकट था वो तो पता है, पर फिर भी इन
हाँ
लोग ने
वो पता, सुनो,
बार बार।
हाँ बट उसमें क्या है, जैसे ऐसे क्या ब्राउजर पे जाओगे, IITM-PS लिखोगे, साइन इन पे क्लिक करोगे, देन साइन इन होगा, ऐसे क्या होगा, तुमको केवल एक बार ही साइन इन करना पड़ेगा, लेकिन साइन इन करना पड़ेगा, ये बदतमीजी मतलब ये बदतमीजी करते हैं ना।
नहीं यार, मुझे ये रिकॉर्डेड मिल जाए बस, मैं क्या करूं, क्योंकि मैं हमेशा लाइव नहीं कर पाती हूँ यार।
नहीं तो तुम्हें लाइव करने की जरूरत भी नहीं है, तुम वही रिकॉर्डेड देखो जो प्रोफेसर ने कराए हैं ना।